Here we go. Maddie, who's my favorite student? Sadly, it's not you. Who's my favorite student, Maddie? Oh, we got to go good old Ann. Sir Key. Okay. You okay with our test next class? We can do it Tuesday or Thursday, but I'd rather do it while it's fresh in our brain, Tuesday. Okay? What it'll be on? A lot of this stuff here. It says expressed in scientific notation, 5.5 times 10 to the what? To the 3? No, don't count the zeros. Count the decimal places. 4. 1 mark. Half mark for the 5.5. Half mark for the 10 to the 4th. Mark your own, Alan. Mark your own. Here we go. 4.2 times 10 to the what? First thing I always do if it's a small number, I write down the negative even before I start to count just to make sure I don't forget. Because it's not like that's never happened. Negative 3 or negative 2? And negative 2. 3.64 times 10 to the negative 1, 2, 3, 4, 5, yes? And 1.236 times 10 to the 1, 2, 3, 4, 5, 6, 7? Is that right? Yeah. 1 mark for each of those. Perform the following operations on your calculator. Multiplying and dividing is a different sig fig rule than adding or subtracting. For multiplying and dividing, 2 sig figs, 2 sig figs. I'm going to go to 2 sig figs. I type it in as written. I go 7.1 scientific notation button, negative 4 times 3.6 scientific notation button, negative 7. Before I forget, on Tuesday, if you show up without a calculator, I'm making you write the test. That's like showing up to work without a uniform and thinking you'll get paid the same as everybody else. No, you won't. You'll lose some marks because you didn't bring a calculator. Oh, that's a shame. My heart will bleed. It won't. So make sure you bring a calculator Tuesday. I get 2.556 times 10 to the negative 10. Now, how many sig figs am I going to go to here, Morgan? So I'm going to look at the 5. Am I going to keep the 5 a 5 or am I going to make it a 6? It's going to become a 6. So 2.6, half mark for that, times 10 to the negative 10, half mark for that. If you wrote 2.6 E10, because that's what your calculator said, half mark, because that's not what it means. That E means times 10 to the 3 sig figs, 2 sig figs. I'm going to go to 2 sig figs. 1.42 scientific notation button, negative 5 divided by 4.3 scientific notation button, negative 50. Scientific notation button, negative 15. If you type it this way, you don't need to put the bottom in brackets. If, despite my warnings, you're still typing times 10 to the power of, and you're not using your scientific notation button, you'll have to put the bottom in brackets and you'll do way more typing. Do it my way. I get 3.3 to 2 sig figs times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9? Or is that a German saying no? 9? 9? Nothing? Really? Okay. Faith, I only need about 5 years worth of jokes, and that way I just seem funny to all of you. Ibrahim's going, you used some of these in grade 9. 9? Yeah, shut up. Adding and subtracting is trickier. In fact, if it's adding and subtracting scientific notation, I usually write it in standard form. 0.0060 plus 0.00035. Looks like the first place I'm missing something is, I think the way I wrote it with you folks, I'm missing something here, so I'm going to round off to there. Now on my calculator, 0.060 plus 0.00035. I'm going to round off to the 4th decimal place. The fourth decimal place is right there. That 3 is going to become a 4, so I'm going to write it as 0.0064. 6.4 times 10 to the negative 3. Whew. Mandy, how many marks was this question worth? Probably 1 mark for the 6.4 and 1 mark for the 10 to the negative 3. Okay? Convert. 3 seconds into milliseconds. I'm going to start out by writing down what they gave me. 3.0 seconds. I want seconds to cancel. I want milliseconds left behind. And I'm going to put the 10 to the negative 3. I don't memorize whether it goes on the top or on the bottom. I memorize it goes where the metric letter isn't. So since the metric letter, the little milli, is on top, the 10 to the goes on the bottom. I get 3 divided by 10 to the negative 3. It's 3,000, yes? Is that correct? I'm doing it in my head, but I'm pretty sure I can divide by that in my head. Yes? 3,000? If you didn't put the units, take a half mark off. Units matter. We watched a phone call with a frustrated customer trying to explain that that was the case. If you wrote it in scientific notation, it would be 3 times 10 to the third, which I would also take. B, that's going to be a 2-step question because I'm going from one letter to a different letter. 25 kilograms. Ethan, my friend, I want kilograms to cancel. I'll go to grams, and that's a 10 to the 3. And then I want grams to cancel. I'm going to go to milligrams, and milli is 10 to the negative 3, which is going to go on the bottom. So on my calculator, I'm going to type 25 times 10 to the third divided by 10 to the negative 3. And lo and behold, I get a 25 with 6 zeros. You know what? This one I will write in scientific notation because it's less work. 2.5 times 10 to the 7th. And this is milligrams. All or nothing. Okay. Half mark off for no units. And again, Colby, if you wrote it as a 25 with 6 zeros, full mark, because I didn't say you had to write it in scientific notation. In fact, really, I'd like you to decide on your own when it's easiest, go scientific notation. When it's not, don't. I think. That's my way of thinking. Convert 1 year into seconds. I'm going to start out writing down what they gave me. 1 year. Except instead of a Y, I should use the proper abbreviation because that said 1 yard. 1 year annually. Does anybody know how many seconds there are in a year? I don't. But I know how many days there are in a year. So I'm going to put years on the bottom, days here. 365 days is 1 year. And I know how many hours there are in a day. I know there's 24 hours in 1 day. And Hannah, I've memorized something because I'm lazy. I know how many hours there are in a second or how many seconds there are in an hour. I know it's 3,600 seconds in every hour. I've memorized that over the years. Oops, wrong folder. Close that, Mr. Duick. Calculator. So did you get 365 times 24 times 3,600? Do you get 31536 and 3 zeros? 31536, 1, 2, 3 zeros, and that's seconds. Or 3.1536 times 10 to the 7th. Here, even though it's a big number, I had to write 5 of the digits anyhow, and by that time it was less work to keep writing the zeros than it was to write scientific notation. But Chantel, if you want scientific notation, I'm fine with that too. You gonna make it, Justin? Because you are not looking awake right now. But I have a solution for that. Ha-ha! I can move around my classroom. I think I'll teach from here for a while. We'll do the Captain Morgan pose right here. Here we go. Next page over. Perform the indicated operations to the correct number of sig figs. Does it tell me to worry about scientific notation or not? Though I don't care whether you do or you don't. 3 sig figs, 2 sig figs. I'm going to go to 2 sig figs. 1.25 times 0.50. And I get to 2 sig figs, 0.63. All or nothing. Not 0.625, 0.63. 3 sig figs. 4 sig figs. I'm going to go to 3 sig figs. So I'm going to go to my calculator and I'm going to type in 51.3 times 3.940. Oh, that didn't type that in right. Second function, enter. 3.940. By the way, on my calculator, I don't need to type that last zero. I'm putting it in just so you can see the sig figs, but clearly it's not going to make a difference. How many sig figs here? 3, 202. Right? Right. 3 sig figs, 4 sig figs. I'm going to go to 3 sig figs. 4.37, scientific notation button 3, divided by 0.00856. I don't really need to type that last zero. Geo will make a difference. How many sig figs? 3 sig figs. 5, 1. This 0 is what I'm going to round to. Is that 0 going to stay a 0 or become a 1? It's going to become a 1, so it's going to be 511. But the answer is not 511. Am I wrong? So far, this is good. I've got to add the zeros in. How many zeros? And that's why these zeros are not considered significant. They are purely placeholders. They are just bumping the 5, the 1, and the 1 over so that they're in the right column. Those are not significant digits. 511,000, yes? Yeah, or 5.11 times 10 to the 5th. I'd take that too. Adding 3 decimal places. 5 decimal places. I'm going to go to 3 decimal places. Geo, that's the shortcut if you don't want to write them vertically. Three decimal places. I'm going to go to this 5 right here. Is that 5 going to stay a 5 or become a 6? It's going to become a 6. 38.126. Yes? No? Am I wrong?
Why is like the 38.0023?
Why is the 38.002? It's not 3 sig figs. It's decimal places. For adding and subtracting, it's decimal places. Okay? Put that away. Focus. Mark. You're marking it? Yes?
Yeah.
Yeah? Okay. Yeah.
38.0023 sig figs or 5 sig figs?
I don't care. It's not, again, let me emphasize, for adding and subtracting has nothing to do with sig figs. It's decimal places. How many decimal places does the first number have? 3. How many decimal places does the second number have? 5. I'm going to round for adding and subtracting with sig figs to 3 decimal places. That's what you'll do if you write them vertically, put the question mark in, and then figure out which column we're going. In other words, here, 2 decimal places. Here, 1 decimal place. I'm going to go to 1 decimal place. It's going to end up being 512.06, take away 65.2. To 1 decimal place, it's going to be 446 point. Is the 8 going to... Or was that a German saying... 9! Okay, 446.9. All or nothing. No half marks on these. You can expect to see a very similar section to this with some of the same weird, quirky types of questions on your quest on Tuesday. I noticed as I walked around, a lot of you left number 6 blank. I like question 6. I like question 6. I like question 6. Question 6 is a nice question. Maddie, why would I say that? Did you hear me say it's going to be on the test? Or you're the kind of student who notices when a teacher tends to emphasize certain things and you pick up on that and you make a little note? Good. You'll do well in my class. Got the hint there, Morgan? Yes? I'll never make that blatant hint again, but you'll pick it up along the way. I'm going to write down what they gave me. They gave me 48 parrots. Instead of parrots, can I use P? I want parrots to cancel, Ibrahim. Where's it going to go in my next fraction? On the? Yep. Now, I looked. I have this conversion factor here. Apparently, 5 parrots are 1 zebra. When I draw a Z, by the way, I'll always put a line through it like that so you know it's not a 2. That's a 2. That's a Z, because my writing is atrocious. Evan, where's the Z going to go in my next fraction? On the? 5. And I can turn zebras into monkeys. Apparently, 8 monkeys is 1 zebra. Geo, where is the M going to go in my next fraction? On the? And monkeys, I can turn into gorillas. 1 gorilla is 6 monkeys. That seems about right. I don't know. I'm just making up numbers clearly, right? And gorillas, Aisha, will cancel, and I can put lions, and I've already done my speech how whenever I draw an L lowercase, I'll always handwrite it, so you know it's not a 1. 2 lions, 5 gorillas, and this, lo and behold, will get me into lions. Anything on top, I'm going to multiply. Any number on the bottom, I'm going to, everybody, divide, and I'm going to ignore the ones. I don't know if this will work out evenly. I somehow doubt it will. 48 times 8 times 2 divided by 5 divided by 6 divided by 5. I think that's right. Do you get 5.12? Now, you're going to say, Mr. Dewick, how can you have 5.12 lions? If you rounded to 6 or to 5 here, I'd be okay with that. But let's do the whole thing. 5.12 lions. Now, if you got that, listen closely, please. That gets you 3 marks. If you wrote down what they gave you, that gets you 1 mark. So if you got this wrong, but you were clever enough to at least try my method, 48 parrots, that gets you 1 mark. If you tried building a chain, even if you did your chain wrong, if you tried building a long conversion chain, I will give you 1 more mark. So you can get 2 out of 3, even if you got the wrong answer, just by saying, hey, Mr. Dewick, I tried your method because it's worth trying. Can you give yourself a lovely score at the top of this quiz out of 19? So we're going to start the official physics part now. It says Unit 3 because I skipped Unit 2. Something had to go with the shorter classes, and so that's what went. In physics, you're going to learn every single quantity, every measured quantity is either a scalar or a vector, and this is hugely important. Anytime I introduce something new to you, as soon as I introduce the new concept, I'll tell you the units that it's measured in and whether it's a scalar or a vector. Scalars have magnitude only. Magnitude is a fancy schmancy word for size. Magnitude is a fancy schmancy word for size. What are some examples of scalars? Time is a scalar. Coming behind you, Guggen. Mass is a scalar. There's more. Vectors have both magnitude, they have size, but they possess a second quality as well besides faith. Does anybody know what the second quality that they possess is? Put your pencils down, look up. Vectors have both magnitude and direction. Your career goals would be a scalar. They have magnitude but very little direction. That's the dumb punchline I always throw at you right now. It's a dumb way to remember. And it damages your self-esteem a tiny bit, so I cannot resist. Examples of vectors. Force. It makes a difference which way you push on something. Velocity. Mr. Dewick, it would be wonderful if there was a clever way that I could remember that velocity is a vector. Mr. Dewick, if you were a good teacher, you'd have some dumb way for me to remember that velocity is a vector. Yeah, I got nothing. Sorry, you're on your own. Everything that I show you, both this year and next, is either going to be a scalar or a vector. So we're going to list a few here. In fact, we're going to list the ones that we're going to be running into an awful lot this year. Sometimes they come in pairs. So I already told you that velocity is a vector. What would velocity be? 30 kilometers per hour due north. And it's that due north that makes it a vector. 60 kilometers per hour, 38 degrees south of west. And that 38 degrees south of west is what makes it a vector. If all you care about is the magnitude, we have a name for that as well. In fact, you learn it as a driver. You call it, when you're driving on the road, the blank limit. You don't call it the velocity limit. What do you call it? Speed. Mr. Dewick? Yeah, Ibrahim. If you were a good teacher, you would have a dumb way for me to remember that speed is a scalar. Mr. Dewick, if you were a good teacher, surely there's some dumb way that I can remember that speed is a scalar. I got nothing. You're on your own. Sorry. I already said that mass is a scalar. And time is a scalar. Acceleration, which I'll abbreviate as accel, is a vector. It makes a difference whether you're accelerating forwards or backwards. If you're accelerating forwards, you're speeding up. If you're accelerating backwards, you're doing the opposite of speeding up. You're slowing down. I already said force. We'll get to force later on this year. But there's two more that you'll just have to plain old memorize. And unfortunately, I don't have a dumb, stupid way for you to remember. Distance and displacement. Distance is a scalar. How far did you go? I went about 60 kilometers. I went about, how far did you walk? A couple hundred meters. Those are scalars. Displacement. How far did you go? Oh, I went 60 kilometers east. Little note. In typewriting, vectors are typically written in bold font, but it's really tough in handwriting to bold font letters. Like there's my bold fonted V. So the other way we show vectors is because they have direction, we put an arrow over them. For years, it was a complete arrow. Don't write that down. We've gotten lazy over the years, and it's just half an arrow like that. That's a vector. That's a scalar. That's a vector. That's a scalar. Vector. We're going to talk about distance versus displacement. This will probably take us till the tone. This isn't a tough concept. The only problem is, Justin, they both begin with the letter D. In fact, they both begin with the letter DI. In fact, they both begin with the letter DIS. So if you can come up with a dumb way to remember scalar versus vector from the T and from the P, great. Let me know and I'll use that for the rest of my teaching, but I got nothing right now. Distance is how far an object has traveled. Symbol. I'm going to be teaching you wrong because it's easier. The correct symbol for distance, if you're British, is a lowercase letter s. What number does that look like? 5. What unit does that look like? Seconds. I hate it. The Brits use the S because that's what Isaac Newton used, because in Latin, the word for distance begins with an S, and it makes sense, and Newton wrote everything in Latin. Cross that out. I showed it to you. We're not going to use it. A better variable which you'll probably use if you take university physics, is the letter X, like on a graph. Traveling along the x-axis, you go forwards, you go backwards. The problem is, sometimes this year, we're going to be traveling up and down, which confuses me, because to me, up and down isn't the letter X. Up and down to me is which letter on a graph? Because I asked you to. Up and down is which letter on a graph? Why? Because I asked you to. Up and down is which letter on a graph? Why? Because I asked, figure it out, Brady, figure it, okay. The letter Y. So I'm not a fan of the letter X, but I just helped a kid yesterday after school who's doing physics at university, and all of her formula sheets use the letter X, and okay. But I'm going to say no thank you. For distance, I'm going to use a D, which is terrible. It'll make sense to you guys, and it's fine this year, but those of you that take calculus will find out the letter D has a very, very specific and reserved meaning. Yeah, it's wrong, but I'm using it. Meters. If at all possible, that's the SI standard units for distance. I hate memorizing stuff, but if I could give you one piece of advice that's worth memorizing, Gio, you'll agree with me, it's worth memorizing what units go with what, because it totally cuts down on your thinking. And if I say to memorize something, Chantel, because I hate memorizing something, if I tell you to memorize something, it's because it's really worth memorizing it. Like, I don't do that very often. So it's worth memorizing what units go with what. Compare that with displacement. Displacement is an object's change in position. Here is the difference. I'd like you to imagine that I am a little particle, a little car, something moving, and that my starting point is right here. I'm going to walk this way. Count my steps, and let's assume each step is a meter. 1, 2, 3, 4, 5. How many steps did I take? Loud and proud. 5. What was my distance then? 5 meters. But what's my displacement? 1. That's my change in position from where I was. I could also have gone like this, back to the starting point. 1, 2, 3. 4, 5, 6. What was my distance, Evan? 6. What's my displacement? 0, because I didn't go anywhere. That's the difference between distance and displacement. I should also add a directional component, call it forward. Or actually, what we're going to do, rather than worrying about direction, we're going to decide forward will represent with positive, backwards will represent with negative. So if you don't put a sign, I assume it's positive forwards. Up will represent with positive. Down will represent with negative. That'll be a nice, easy convention. To the right will represent with positive, like on a graph. To the left will represent with negative. Or you can write the words right and left, but I tend to abbreviate, so I'll use the symbols. Symbol for displacement should be an S, no. Should be an X, no. I'm going to use a D. Try that again, Mr. Duick. That's a scalar. Look up, look up, look up, look up. Everybody look up. That's distance. Behold, now it's a vector displacement. We use the vector arrow. I am not going to take marks off if you use the wrong symbols. The loss of marks will take care of itself, because probably if you're using the wrong symbols, if you forget the vector arrow, probably you forgot to take into account direction, and rather than the answer of 1 or 0, you'll be giving me the answers of 5 or 6. So it'll take care of itself. So I am careful with my notation, but also here's where I suck as a teacher. Gio can attest to this. To this day, I'm teaching now physics for 12 years. Verbally, I still mix up distance and displacement because they both begin with a dis. So I'll catch myself often. Sorry, I said distance. I should have said displacement. You're going to hear me do that fairly often. Sorry. When objects are moving, it's useful to be able to describe an object's location. To describe location, one way is to imagine them sitting on a graph, or just to imagine a meter stick is placed right next to the object. The meter stick acts like a number line. We'll say objects going to the right have a positive value, objects going to the left have a negative value. These are just positions, these are just locations. So here's our first example. A bug walks along a number line, little beetle. It starts at location A, walks to B, and then turns around and walks to C. First of all, I want to draw that. How would I draw that? I would do something like this. I would draw an arrow pointing from A to B, because that's the first journey that it took. Where does it go then, Aisha? So, look up. I don't want to go back through the line. That's confusing. And so what we typically do is we just go a little bit higher. That's meant to show a little bit later. That would be its path. If it did another trip, I'd do another line above that, showing where it ended up. I find the pictures are very visual and help me with this. You're writing this down, yes? What distance did the bug walk? Give me the obvious answer. This is the easy part. Distance isn't too bad. How far did the bug walk? 10. Units? 4 plus... Is it 10?
14.
What? 4 right? And 10 left is total of 14 steps, 14 meters. Is that okay? Now, what's the displacement? Displacement doesn't care about the path to get there. It asks, where'd you start? Where'd you end? That's it. What's the displacement? The change in position. So I would accept two answers. If you said negative 6 meters, or you could say 6 meters direction. Looking for words that begin with the letter L and rhymes with heft. I would take either of those. I prefer the first one. Here's what I would not take. If you said negative 6 meters left, I would argue, what's negative left actually? Think about it. What is it actually? Right? Right. Right? Right. That one, I would take a mark or a half mark off. I would say, no, one or the other, but not both. Turn the page. Example 2, here's a conceptual question. It says this: suppose that you run along 3 different paths to get from A to B. Along which paths would your distance traveled be different than your... Oh, hang on. Pause for 1 second. Hang on.